So Wiesner had a bunch of things in his conjugate coding paper. One of these was a method to encode two pieces of information in, well, with different bases, so that the receiver had a choice of decoding one of them or decoding the other. And of course, what you do is you encode one of them, well, using error correction with the horizontal vertical basis, and the other with the diagonal basis. And now, if you measure each of them in each of these things, each of these photons in a separate basis, there is no way you can choose a set of bases to learn both of these things, both of these strings. But of course, there's lots and lots of other measurements. It turns out that there is a measurement, which is a complicated entangled measurement you can make, which tells you both these bit strings that the sender is trying to let you have the choice of seeing one or the other. So that piece of the paper actually doesn't work with quantum mechanics. And Wiesner's banknotes paper really does work with quantum mechanics, although the disadvantage of it, using this as quantum money, is to verify that this quantum money is really valid, you have to call up the bank, because it depends on, so the idea was the bank knows which basis each qubit is encoded in, but the merchant doesn't. But then if a whole bunch of merchants got together and each of them looked at these notes, and they would call up the bank would tell them which qubits to measure in which basis. If they got together and sneakily collaborated, they could actually learn enough information to forge the banknote. So this is not really a great way of doing quantum banknotes. So I and some, Eddie Fari and some former graduate students at MIT have proposed a different way of doing quantum banknotes, which is actually much more cryptographic, in that we use knots and knot invariance, and there's some task that depends on knot invariance that we're assuming you cannot do with a classical computer. In fact, you're assuming you can't even do it with a quantum computer. So this is a possible scheme for quantum money, which nobody has broken yet, but nobody is really that sure is secure, because nobody in classical cryptography uses knot invariance. So it's not at all clear that there's not some sneaky way to, sneaky classical algorithm that will break this quantum money system.